Every project manager has to balance scope, cost, time, resources, risk, and quality to achieve project success. Time and cost can be checked against the project schedule and budget, but what is quality, and how do you know when you have delivered it? According to the ISO 9000 family of quality management standards, quality is the degree to which a set of inherent characteristics fulfill requirements. In other words, quality is the sum of project and product characteristics that help fulfill customer requirements. So, product quality is a very important part of project management. If you fail to establish and carry out good quality management, there could be serious consequences for the team, the organization, the customer, and the product. This topic covers several of the tools and techniques used to control quality. We'll start with cause and effect diagrams. This is a cause and effect diagram. They are also known as fishbone diagrams because they look a bit like a fish skeleton, or Ishikawa diagrams after a Japanese quality guru. They show the relationships between the effects of problems and their causes. In the top diagram, the possible causes for the major defect have been identified and placed along the spine of the diagram. In the bottom diagram, each one of the causes is further broken down into its related factors or subcauses so that you can analyze and investigate the problem. Another commonly used quality tool is the flowchart. This is a graphical representation of a process. It allows a project team to create a map of the events in a process. By examining flowcharts carefully, project managers can often identify gaps in workflow that could cause quality problems and errors. Flowcharting can also identify inefficiencies in the quality process. Check sheets are used as a tally sheet to gather data. They are typically in the form of a table that organizes data according to product features and performance metrics. Check sheets can be used to spot anomalies and trends. There's also the Pareto diagram, named after its creator, Vilfredo Pareto. A Pareto diagram takes the histogram one step further by adding cumulative percentages. The causes are arranged by frequency so that you can easily see which causes are creating the greatest number of defects. You apply the Pareto principle or the 80-20 rule to identify the 20% of causes that are causing 80% of the defects, in this case, personnel and materials. This helps you establish priorities in terms of implementing corrective action so that causes resulting in the most defects are addressed first. Histograms are vertical bar charts. You use them in the control quality process to help identify and rate the causes of defects. The y-axis displays the frequency of defects, and the x-axis displays the identified causes of the defects. Each column represents an attribute of a problem or situation, such as the causes of late time card submissions by a project team. The relative frequency of each attribute is represented by the height of each column. Control charts are used to monitor performance of a process over time and against established control limits. Although a control chart is most often used to track repetitive manufacturing activities, it's a versatile tool that can also be used to monitor management indicators, such as costs, schedule, volume, and frequency of scope changes. The distribution of the data points on the chart determines whether the process is performing within prescribed limits. A control chart shows you the upper control limit, the lower control limit, and the mean. If there are any points outside the control limits, your process is considered to be out of control. When the results of a process remain randomly distributed within control limits over time, the process is said to be in control. A scatter diagram is also a graphical illustration of data. However, scatter diagrams display information about the relationship or correlation between two variables in a process. For example, a scatter diagram may reveal a correlation between the time project team members must spend traveling and their ability to submit time cards on time. The greater the number of days spent traveling, the later the submissions. On a scatter diagram, you can have different degrees of correlation. A strong correlation exists if the values of an independent variable have a substantial effect on the values of the dependent variable. In a scatter diagram, the closer the plotted points to a diagonal line, running either up from where the axes intersect or down from a high value, the stronger the relationship between the two variables. Data points that aren't close to the line indicate a weak correlation. Randomly scattered points on a scatter diagram indicate that there is either no correlation or an insignificant one between the independent and dependent variables. In summary, there are several tools and techniques that can be used to control quality. They are cause and effect, known as Ishikawa or fishbone diagrams, flowcharts, check sheets, Pareto diagrams, histograms, control charts, and scatter diagrams.